Alright, our next topic is OOPS, that is Object-Oriented Programming. The object-oriented programming approach is based on certain concepts that help it attain its goal of overcoming the drawbacks or shortcomings of conventional programming approaches. These are of 5 types as shown: data abstraction, data encapsulation, modularity, inheritance, and polymorphism. Let's discuss these concepts in details to understand their meaning. The first one is data abstraction. Abstraction refers to the act of representing essential features without including the background details or explanations. For example, while driving a car, you only know the gear handling, steering handling, use of clutch, accelerator, brakes, etc. But you do not get to know the internal details of car like wiring, motor working, etc. What is happening inside is hidden from you. This is known as abstraction, where you only know the essential things, for example here driving a car, without including the background details or explanations. Another example of abstraction is switchboard. You only press certain buttons and switches according to your requirement. What is happening inside and how it is happening, etc., you need not know. This is the concept of data abstraction. The next one is encapsulation. The wrapping up of data and operations or functions that operate on the data into a single unit is known as encapsulation. For example, in a big company, there are several departments, that is sales, accounts, payroll, purchase, production, etc. Now suppose an employee in the production department wants to know some details about purchase department. The production department employee would not be allowed to go through the purchase department data files. Rather, some employee of the purchase department will go through the purchase data files and send the reply with the asked information. This practice ensures that the data is accessed accurately and that it is not corrupted by outsiders. Therefore, we can say here that department data and department employees are encapsulated into a single entity, that is the department here. Now, an important point is that encapsulation and data abstraction is interrelated. Encapsulation is a way to implement data abstraction. Encapsulation hides the details of the implementation of an object. The third one is modularity. Modularity is the property of a system that has been decomposed into a set of cohesive and loosely coupled modules. The music system, for example, comprises of speakers, cassette player, record players, CD players, tuner, etc. Now, each module is a complete unit in itself, yet it works in accordance with other modules in order to achieve one single goal, that is music. This is known as modularity. In C++, functions can be considered as an example of modularity. Now the fourth one is inheritance. Inheritance is the capability of one class of things to inherit capabilities or properties from another class. For example, we human beings inherit certain properties and characteristics from our ancestors. Similarly, the class car, which inherits some of its properties from the class automobiles, which inherits some of its properties from another class, vehicles. So this capability to pass down properties is known as inheritance. Now, inheritance gives the idea of reusability. It allows the addition of additional features to an existing class without modifying it. One can derive a new class or a subclass from an existing one and add new features to it. Suppose we have a class chair and we need to add a new class called wooden chair. We derive the new class wooden chair from the existing class chair, and then all we need to do is add extra features to wooden chair that describe the differences between a chair and wooden chair. So this reduces the amount of typing, of course, and the efforts that are put in. Now the next capability that inheritance has is its transitive nature. For example, if a new class wooden chair has been declared as a subclass of chair, which itself is a subclass of furniture, then it implies that wooden chair is also a furniture. That is, inheritance is transitive, which means that if a class A inherits properties of another class B, then all the subclasses of A will automatically inherit the properties of B. This is the transitive nature of inheritance. The last one is polymorphism. Polymorphism is the ability for a message or data to be processed in more than one form. For example, if we have the functions named area circle and area triangle as shown in the example, then the function area performs differently for circle and differently for triangle. Therefore, polymorphism is a property by which the same message can be sent to objects of several different classes, and each object can respond in a different way depending on its class. Till now, we have completed the basic concepts and terminologies of C++. Now let's see how to write programs in C++. Okay, so let's open code blocks. Now since we have to create a new project, so we'll be clicking on create a new project. Now in other case, when we have already created a project and then we have to open that, then in that case we'll click on open an existing project. But now here we have create a new project because we are going to create a new one. So click on a create a new project, come to console application and click go. Next. Now we are using the code and learning the code, learning about C++. So we'll click on C++ and come to next. Project title is something, a name which we are going to give it to our program. So here I'm going to give any name that you can think of. I'll give first. And now this is the location where we have to store our program. Click on next. GNU-GCC compiler is the compiler which we are going to use always, so do not change it. Click on finish. And this is the workspace that we have, and this is the program name that you have given, your program name. I have given it first, so it will come here. Click on sources, main. So this basic model will automatically appear on your screen, but since we have to create one, so I'm going to delete this, and we're going to create a new one. So let's see, I'll explain each line, but for now let's print it. Okay, so you can print anything that you want, So the first program that we are going to do is to print a string on the screen. Okay, so we have to display any string that we want to on the output screen. So that it can be any string of your choice. I'm printing this is my first program. Alright, this is what I want to print on my output screen. So this is it. And then don't worry, I'll be explaining each line. Okay, so this is done. So now we'll build it. Okay, just to see whether there are no errors and all. And when that's done, like you can see here, there are 0 errors, 0 warnings. So program is completely perfect. And then this green button that you can see, then here you can click to run it. And here my output screen reads, this is my first program. So our output is perfect as we wanted. So press any key to continue. Here it is. Now let's see what each line means. Here I have IO stream. This is known as the header file. Alright, this is known as the header file. So what is header file? Header file contains the definitions of functions and variables which is imported and which we are going to use into any C++ program. And by using what? By using the preprocessor. Now what is preprocessor? This hash include. This hash include is the preprocessor. This whole thing, hash include, is known as the preprocessor statement. So this hash sign is the directive for the preprocessor, which means that these statements are processed before the compilation takes place. Alright, so basically this header file IO stream provides us with input and output streams that will come here. See out. This is the output stream. This is the output that we have used. See out. This is the O stream, output stream, as you can see here. Alright, so for this header file is for the output stream and input stream. So O stream is for output stream and I stream is for input stream. That's what it is, IO stream. Okay. So next we have using namespace standard. So what is it? This using namespace standard, this tells the compiler to use standard namespace. It holds its own definitions for variables, functions, etc. As the header file stores a definition for the functions and variables which are used in the program. Similarly, this using namespace standard tells the compiler to use the standard namespace and it holds its own definitions for variables, functions, etc. It is used to organize the code into logical groups and to prevent name collisions that can occur, especially when your code includes multiple libraries. So there, this using namespace standard is useful. Next comes int main, which is the most important part to start any C++ program. So the main function is the function which holds the executing part of the program. In fact, the content of main function is always the first to be executed when a program starts. And hence it is important that all the C++ program must have a main function. So why am I calling this main as function? Because as in the previous modules, in the previous module I have mentioned that in a function, this this sign is it's indicating the function. So main is a function. All right. Now int. This int is its return type. Now return type means what kind of value is being returned to the main. Okay. So here, since we are not returning any value, therefore the at the end you can see here that we have returned 0 because we are not returning any value. All right. Now here we can also use void main, since void means null, so we can use void as well. Let's try doing it with void. Okay, so if we are removing this int and if you're using void here and just try executing it, there will be no error. Simply the output is there. So since we are returning no value here, so you can use void also. Okay, so next comes the curly braces. There are two curly braces, one open and one closed. So every function in C++ has its code included in a pair of curly braces. So here this code, this whole code is between these two braces, and this is a code of function main here in this program. All right. Now the next line that we have is this cout. This is my first program. So let's see it word by word. So cout, as I told you, it is the standard output stream in C++. Therefore, to print anything on the output stream, cout has to be used, and this is the operator that is used for cout. All right. Now, any statement which needs to be displayed on the output screen has to be within double quotes as shown. This double quotes. So anything that needs to be printed. For example, here we had to print this statement. This is my first program as our output. So this has to be within the double quotes. And finally it ends, and then we obviously write whatever we want, and then the statement is ending with a semicolon, as we can see, right? So this semicolon is used to finish every executable statement of a C++ program, and it has to be included after every executable instruction. And also note that these hash instructions are not considered to be executable instructions. Okay, so this is done, and then finally obviously we end it with our curly braces, the closed one, to end our program. So this is how a basic program looks like. So now let's have a look to few more programs, and then it will be more clear. Here's my second program to print the sum of two values. Now here I'm continuing in the same code, but you may start a new one by creating a new project. So let's start. I want to print the sum of two values which are of integer types. So the data type int for integer values, and then two values separated by commas, and then there's a third value in which I'll be storing the values of the result of the values. So for that I'm taking one more value, semicolon. Now let's initialize the values. I want the sum of, suppose for example, 2 and 5. So let's initialize it. Value of a, I'm initializing it as 2, and then value of b, I'm initializing it as 5. So here what is happening, first we have declared the values a, b, c, and then I have initialized them as a is equal to 2 and b is equal to 5. In previous modules I have explained the declaration and initialization of variable. Now, as I said, C is for storing the result. So what do I need to do? Print the sum of these two values. So let's put the formula a plus b, semicolon. So it will add the two values and store the result into the third variable, that is c here. So what we need to print is c, because the result is now stored in new variable, that is c. So c out, as we know how to print it. Now let's, the result is equal to this we need to print on the screen, so that's why it is between the double quotes, and then the output operator, and then c. So the value, since the value is stored inside this variable, so we need to print the value which is stored in the variable. Hence will not put the this variable under the double quotes, c, and then return 0. So let's build it. So, and there are no errors and warnings. Let's run it. So the expected output is 2 plus 5, 7. So let's see whether the output comes or not. The result is 7. So here's the one way to do it. Let's see another way. If we are not declaring it at all, if you are not declaring and initializing it at all, how can we do it? We'll simply write the sum of 2 plus 5 is equal to and then just for indentation we can write in the next line, see out, we can directly put the values 2 plus 5. Alright, so let's see the output. We're getting no errors and no warnings. We'll run it and we should get the same output. Yes, we are. The sum of 2 plus 5 is equal to 7. This is another method that how you can do it. Now okay, so this is done. Now if you want to print another set of values sum, so like suppose for example I am that the result of 5 minus 1 is equal to see out 5 minus 1, right? Okay, now I'll tell you what will happen here is that the output will be the sum of 2 plus 5 is equal to 7. The result of 5 minus 1 will be 4, and these two statements will be in a continuous line. Let's see. Okay, we haven't built it, so that's why it's coming. Let's build it. Okay, so no errors. Let's print it. So as I said, the sum of 2 plus 5 equals 7 and the result of 5 minus 1 is equal to 4. They are coming on the same line. So this is okay, but if we want them to be on the separate line, in a separate line, how can we do it? After first result, just put one statement as end L, which means end line. Or you can also use backslash n under the double quotes and semicolon. Either of them. These both statements mean end of line. So here when we now run it, we'll get on two separate lines. Alright. So now like this can be end L also. Now what is this? This is known as comment. So this line, see now if I run it, this end L, which is after two backslashes, this will not be printed. This will not be displayed on the output screen. So if when we run it, it's the same. So these are comments which are used to which is just used to enhance the readability or understandability of the program. So basically we have two types of comments, that is single line comment. This two backslashes means that it is used for single line comments. So the compiler simply ignores everything following in that same line. And similarly we have multi-line comments for multiple lines. So there we use, if suppose we want, okay, I'll do it here. Multiple line comments is backslash asterisk, and after that whatever you write will be, if suppose we do not want the second this result, we can use multiple line comments instead of deleting the whole thing. So we'll be doing it as backslash asterisk, and then at the end of this we need asterisk and then backslash. So now there will be only one output, one result displayed on the output screen. That will be the sum of 2 plus 5 will be 7. 5 minus 1 will not be displayed. Let's see. Let's build it. And now run it. There's only the sum of 2 plus 5 is equal to 7, and then a space after that because we have end line statement here.